In this lecture, we are going to talk about the composition of solutions. So first, let's review what a solution is. A solution consists of two parts, a solute plus a solvent. Now, to define what each of these words is, let's fill in the blanks. The blank is dissolved in the blank. So the solute is what is dissolved in the solvent. Typically, there is more solvent than solute. And there is typically a very small amount of solute dissolved in a much larger volume of solvent. The solvent is often, but not always, water. Water is the universal solvent, it's the biological solvent. But the solvent can be any other liquid. The solute sometimes, for example, is a salt, but it can be any other molecule, depending on what kind of solution that you're making, really. So for example, a solute could be sodium chloride dissolved in a solvent water, and that would make a saline solution, a sodium chloride solution. Now, what I want to do in this lecture is talk about various units of concentration, how we quantify how much solute there is in a solution, basically. Now, the one that you've seen before, the classic unit of concentration in general chemistry, is molarity. We denote molarity with a big capital letter M, and what it stands for is the number of moles of solute that you have per liter of solution. And here, what I really want to emphasize in defining this denominator is that you have to remember that the solution consists of the solute as well as the solvent. So if they both have volume, you need to add them together to get the total number of liters of solution for the denominator in molarity. So we abbreviate this with a large capital letter M, or sometimes just with moles per liter. And the adjective that we use to describe this is molar. Now, mass percent. Mass percent is another way of expressing the concentration of a solution. So you'll see it sometimes as percent by mass. And it literally is a percent focused on the mass. So if we take the mass of the solute over the total mass of the solution, okay, it's got to be over the total. So once again here, the denominator includes the total mass of the whole solution, the total mass of the solute plus the solvent, and multiply by 100 to get a percent. That is the definition of mass percent. You could also do volume percent using the volume of the solvent, of the solute rather, over the total volume of the solution. But in this chapter, we tend to focus on mass percent. Now, the other two units of concentration that we're going to use in this chapter are molality. Notice this is one letter away from molarity, but they are very different. Molality is denoted with a lowercase letter m rather than an uppercase letter, and it stands for moles of solute. So the numerator is the same as molarity, but the denominator is different. Kilograms of solvent only. So molality is very different because the denominator only takes into account the solvent, not the whole solution. The final unit of concentration that we use in this chapter is mole fraction, and it's denoted with a capital Greek letter chi. So, for example, if I say I want to figure out the mole fraction of component A, it is literally a proportion with the number of moles. So N is the number of moles of component A, and this would be over the total number of moles of all of the components in the solution. So another way of expressing this would be if I have components A, B, and C, the number of moles of component A over the total of the number of moles of component A plus the number of moles of component B plus the number of moles of component C, et cetera, et cetera, et cetera. So this is a unitless quantity because it is a proportion. So there are no units of mole fraction. It's just a mole ratio of each component in the solution over the total number of moles of all the components in the solution. So what you need to practice doing is interconverting between these 4 units of concentration. Let's do an example. In this example, I would like you to figure out how you would prepare a 15% potassium chloride solution in 100 milliliters of water. This is a very practical problem. You might do this if you're prepping a lab, for example, and you need a 15% KCl solution. Now, 15% KCl implies by mass, okay, so this is, unless you're otherwise told, this is implying a mass percent, right? And for problems like this, you may not be told this, but you can safely assume that the density of water is 1 gram per milliliter for calculating interconverting between volumes and mass of water. That density is safe to use. Whenever we do a problem like this, I like to start with the definition of the unit. So here, because I'm working with mass percents, I want to define what mass percent means. As we just said, mass percent is literally the mass of the solute, which here is what? Well, it's KCl, over the mass of the solution. Now, the mass of the solution encompasses both the KCl and the water, okay? Because remember, solution is solute plus solvent. So I need to figure out what the mass of each of these things is. Now, the problem told me that I want to prepare the solution in 100 milliliters of water. And I know that the density of water is about 1 gram per milliliter. So I can assume that 100 milliliters of water is going to be equal to 100 grams because of that density, 1 gram per milliliter. So that's going to help me with the denominator because water is the solvent. So I know the mass of the solvent. Now, I know the only other thing I know is the mass percent, the 15% KCl. So that mass percent value of 15%, I'm going to express it as 0.15, is going to be equal to the mass of the solute, which I don't know yet. That's what I'm trying to figure out. So I'm going to call it X. X grams of KCl over the total mass of the whole thing. And the total mass of the whole thing is going to include the mass of the solvent, which is water, and I know that's 100 grams of water, plus the mass of the solute, which is the X grams of KCl. So in order to figure out how to prepare this solution, I simply have to solve for X. So if you do the algebra, you have 0.15 times 100 plus X equals X. You can collect all the X terms on one side and solve for X, and X comes out to be equal to 17.6. It is in grams, and this is the amount of KCl that you would measure out. So the question asks, how would you prepare this 15% KCl solution? You would weigh out that mass, 17.6 grams of KCl, and you would add it to 100 milliliters of water. From a practical standpoint, the best piece of glassware to do this in would be a volumetric flask, a 100 milliliter volumetric flask. I hope that this makes sense to everybody. And in subsequent lectures, we will practice additional concentration unit interconversion problems.